Hi, in today's video, I'm quickly just going to demonstrate data mining inside of SQL Server Analysis Services. Now, to understand data mining, probably the first thing that needs to be explained is what is data mining and how is it different from, say, analysis per se. Uh, Inside of SQL Server, we've got obviously the database engine, and then we've got analysis services, which is mainly basically meant for working with very large volumes of data. The primary reason why people work with such large volumes of data is to understand exactly the relationship between the different business processes or the buying patterns of customers, things like that. And one aspect of it is to answer questions related to what happened. Typically, it would be things like what was our profit the previous year, or how are sales improving year on year, things like that, where you essentially look at your previous data and arrive at a specific value which tells you exactly um, what's happened. Now, the other part of that same question or that same puzzle is what is likely to happen, or what is the probability of something happening, which is basically what we call forecasting. Now, data mining typically relates to the second part, which is forecasting, and the intention here is basically to look at patterns, look at information that you already have, and then arrive at a likelihood of something happening, probabilities of things happening. Now, the good thing about SQL Server Analysis Services is that it comes with about 9 data mining algorithms inbuilt. And today, the one that we're going to look at is called decision trees. Now, the intention with decision trees is basically it tells you what is the probability of something happening, the likelihood of something happening. The intention here being that if you have a number of parameters, it looks at those different parameters and then predicts the relationships between each of these parameters and their values, and gives you an idea about what is the likelihood of a certain combination of events happening, or what is the likelihood of something happening based on existing information that you already have. Now, whenever I do data mining trainings, typically the way that I do it is, rather than just pick a random sample and look at data, we heavily load the dice, where we define very specific patterns in the data so that we can look at the data and understand that things are behaving exactly the way as we had hard-coded the values. So this way we know that our models are correct and they're working properly. So today, for this example, what I'm doing is, if you look here, I've got a very simple Excel sheet where I've got 4 columns. One is called gender, the other is pregnant, which is a flag of true or false, and then you got the age, and then you got bearded, which is basically whether the person has facial hair. So you'll see that I've tried to create this in terms of some somewhat realistic scenario. So if you look here, if I choose female as the gender, you'll see that bearded is 0, obviously, because the assumption being that women don't have facial hair. And similarly, if you go to men, you'll see that we've got men with bearded true and false, because some men have beards and others don't. However, what you'll notice is that the way I've done this is people in the age of 14 or below the age of 16 are basically kids, and they don't have facial hair yet. So I've tried to keep it somewhat realistic, even though the information is heavily loaded. The idea being that everybody who's above the age of 16 definitely has facial hair. And that is obviously not realistic, but at least this way we know when we look at the data, if we got someone who's above 16 years old and they've got 0 facial hair, then we know that the mining pattern is probably incorrect. The same thing goes for is pregnant field as well. So if you look over here, if I expand this and I say choose all females, and if you look over here in terms of age, what I've done is I've tried to go ahead and keep this a bit generic. So you'll see that when it comes to pregnancy, I've still got somewhat a spectrum from all the ages, but at the very high level, if you look at it, let me just go ahead and just quickly show you a pivot of this data just so that you can understand the distribution. So if I look at the age as a row and is pregnant as a value, and then I choose gender and set that to female, you'll see that the probability of pregnancy increases significantly with the ages 25 till 54, and then drops significantly after 55, and the same thing for the lower age groups as well. So this is basically just to give a slightly different variation where the rules are not so tightly set. So this is the data that we're working with. So I want to do some analysis. I want to figure out what is the percentage, what is the likelihood, what are the patterns in the data to predict pregnancy or facial hair basically. Now I've already loaded this data into the database. So if you see here, I've got my MathWorks database, and then I've got a table called data, inside which I've loaded all the data, and I've also got a primary key identity column which is called RID. For simplicity's sake, what I've also done is I've gone ahead and bucketed the different ages. So I basically did select distinct age, and then I bucketed the data in terms of the different age groups, in terms of, you know, teens, young adults, adults, children, infants, things like that, just to get a little bit more bucketed kind of aggregate data. So now that we have this, the next step is to obviously create our data mining. So for that purposes, I'm opening up Visual Studio. Now, a lot of people misunderstand that you need analysis services for, or you need a cube for doing data mining, which is not the case. For example, in this particular scenario, I'm not going to use a cube. So here, if you look at it, basically, I'm just waiting for this to open up. You'll see I've already got a data source, which is connected to my MathWorks database, as you can see here. And I've got a MathWorks data source view, inside which I've got a flat table. And you can see here the flat table is actually a view, which is simply nothing but a join. So let me just go ahead and show you that view. It's a join between, it's a join between the age table and the data table. As you can see here, it's a left outer join, so that I can get the age group along with the remaining data. And this is the view, that this is the data that I'm going to work with today. So you can see here I've got the flat table. I've also got a cube here, but that's not really what I'm going to use right now for the data mining, so we can just leave that aside for the time being. So the first thing is obviously to create a data source, which is fairly simple. You can just simply right click, new data source, press next, and then press new and type in the information and then press OK. When you're done with that, you'll have an entry here, and you can just simply go ahead, press next, give it some credential that has permission to talk to the relational database, and that will be your data source. Next one is the data source view, which is basically a layer of abstraction. So all you need to do here is add the table. So you'll see a list of your tables here. You just select it and move it aside to the right by clicking these arrows. When you've done this much, you've got your data source view configured, and the next step is to create your mining structures. So in this case, what I'm going to do is I'm going to use decision trees. So you can see I'll come under mining structures. Now I'll click new mining structures, and I'll press next. You'll see that we have an option here that says relational database, and then we've got cube. So what we want to do is relational database, so I'm going to select that first option there and press next. The default option, as you can see here, is Microsoft Decision Tree, which is the one that we're going to use, and you'll see there are a couple of others here as well, which I'll be covering in future videos. So Decision Trees is the one that you need to select and then press next. Again, it's asking you for the data source because again we're choosing a relational database, so select MathWorks, press next. And in this case, now it's asking you what is the table that we're interested in working with. So typically, if you have multiple tables, one of them will be your main table, and then if that has a primary key foreign key relationship, then the other table would be the nested table. Now I've gone ahead and created a joined view already, which is my flat table, so I can simply select flat table like this here instead of choosing data, which is having a nested table called age. So I'll choose flat table here and I'll press next. And the next question is to identify what are the columns that we're working with. So in this case, the key column is obviously the primary key column, which is RID. And I want to predict the likelihood of pregnancy. So that's why I'm going to go ahead and select is pregnant as the prediction column. Then I'm going to go ahead and assume that there are certain columns here that decide the probability of pregnancy. For example, I'm assuming age, I'm assuming group is definitely one of them. Age is definitely one of them, and gender is definitely one of them. So I select these guys and I say that using these three columns predict the value of is pregnant. So now that we've done that, the next thing is obviously to go ahead and select our ID as a primary key and press next. Here you'll see that we're looking at the data type of the different columns. So in this case, you'll see that it's looking at the data and using probably what it thinks is the best likelihood of that particular data. And then the content type is basically the nature of the data in terms of if you look at continuous, it means you're looking at something that's a range, say 0 to 1000, where the value of 1000 has significance in terms of its position with respect to 0. So 99 or 25 has some meaning in terms of how far away it is from 0 or any other subsequent value before it or after it. Discrete values don't have any relationship. For example, the value male and the value female are two discrete entities that do not affect each other in any real way. So that's where discrete comes into picture. There's obviously a lot more here, but we'll go ahead and just simply click detect now. It'll look at the data and identify the different types of information here. So you'll see that it automatically went ahead and said everything is discrete. So that's good enough for us, and we'll press next. And the next step here is to identify two sets of data. Now obviously we're doing predictions, so we need something, a reference data set against which we can compare our result set or our output. So the idea here is that if you have 100 rows, we will carve out 70 rows which will be used to learn the different data patterns in your results, and then the output of that, basically the assumptions we make based on that data, is evaluated against the remaining 30% or the remaining 30 rows to figure out whether we actually came up with the right algorithm or an algorithm that makes the most sense. So that's what this 30% is over here. The maximum number of cases is basically how many different times it needs to do the test to validate whether it's working properly. So we'll go ahead and press next over here, and we'll create a mining structure called flat table, and we'll press finish. So with this, we're actually done with the mining structure. The next thing is to validate whether this has done the job properly. So if I come into mining models here, and if I come into model viewer here, you'll see that it's asking me to first go ahead, deploy and process the cube. So I'm going to go ahead and do that now. So just a second. So the deployment is done. The next thing is obviously process the cube. So I'm going to go ahead and press run. This might take a few minutes because again this is a relational database rather than the cube, so it's gonna go ahead and do a lot of selects on the underlying table. I've used Excel here, so I'm looking at about 1,000,000 rows, and it should complete fairly quickly. Great. So now that that's done, we are ready to look at our data. And as you can see here, we've got our mining model that's completed its analysis. And as you can see here, we've got tree is pregnant, and the background is for cases is equal to 1, which means that show me all scenarios where the likelihood of someone being pregnant, or basically pregnancy flag being set to 1, is high. So as you can see here in this particular case, as soon as I select that, you'll see that certain fields or certain boxes here became dark blue, because those boxes indicate a high probability or a high likelihood of the pregnancy flag being equal to true. So you'll see that again, based on what we discussed, you'll see that for the most part, for every age that we selected, you'll see that we've got different breakups of gender, basically. So if you just come over here, you'll see that at the age of 45, if you're a female, there's a 100% probability of pregnancies, and obviously male there's 0, so that's why you got 0 here with 100% probability here. So this is basically what data mining will do for you, where it correlates the information from multiple columns to kind of find out how the value in each column has an effect on values in other columns. So as you can see at 37, 38, and 22, for example, if you look here, you'll see that it's showing that under males there is a probability of 3.12 pregnancy. So it's not really looking at the exact information. There is obviously a margin for error because it's again doing a prediction, but based on the data that it saw, It's kind of basically just giving you what it thinks is the best estimate for the likelihood of something happening or not happening. So if you see here again in 28, we've got a very high probability of female with pregnancy is equal to 100%. So the intention here is that this is basically what data mining can do for you. A simple example here in this case, for example, would be that uh, if you look here right now, we've got each and every age listed individually, and that's kind of a problem for us because we need to keep scrolling up and down, which is where I think the group would have been a very good choice for us to aggregate the data. So in this case, if you see here, I've got age as an input here, so I'm going to go ahead and tell it to ignore the age and instead use the group. So this time, if I go ahead and save this and then come back to the mining model, you'll see here it says that I need to deploy and process it again. So I'll go ahead and say yes. And this time you'll see that instead of having many different ages listed individually, we've got a much more smaller chart that explains exactly what's happening. So if I press pregnancy likelihood is equal to 1 as a background value here, you'll see that under young adults there is a 39% probability that there's a high risk of there's a high probability of pregnancy being equal to true. And if you see here under adults and under middle age, if you're a female who's either an adult or middle aged, then there's a 100% probability that you're likely to be pregnant based on the data set that we have. So this kind of validates the hard-coded values that we use to kind of ensure that we're actually able to see results that we know to be true or false. So as you can see, this is basically what data mining or more specifically decision trees can do for you. And we use it quite frequently. In fact, I remember an example where we used it to find out the incidence of diabetes among patients for an insurance company. And obviously that's just one example. There are other examples where we use it to identify the likelihood of a server crashing based on historical data that we've captured from other servers as well. Essentially looking at the error messages and the type of errors and the configuration of the server, we predict which configuration servers are likely to crash under what scenarios. Now obviously there's no guarantee that they will crash or won't, but at least we have an idea about which are the weak spots in our infrastructure. So yeah, this is basically data mining for you. Obviously there's a lot more to it, such as DMX queries, etc. And we've not really covered the mining charts as well, lift charts, etc. But for the most part, with just this much, you should be able to start seeing interesting patterns in your data. And I hope you've enjoyed this video, and thank you for watching.